Assalamu alaikum students. Welcome to our online chemistry class of Cosmic School. Hope all of you are very fine and safe at home by the grace of Almighty Allah. In my previous class, I have discussed about the alkenes. Today I will discuss about the alkyne, which is also an unsaturated hydrocarbon. What is alkyne? Alkyne is unsaturated hydrocarbons in which at least one carbon-carbon triple bond is present in the carbon chain. Here you can see some examples. This is the first member of alkyne group. We know, students, for any carbon-carbon double bond and or the carbon-carbon triple bond, we need at least two carbon. That's why the first member of alkyne group is ethyne. In this example, you can see there is present a carbon-carbon triple bond, and the second one is propane, which is also contains a carbon-carbon triple bond. Here also a single bond is present. In this is the chemical formula of butane. In this also a carbon-carbon triple bond is present. All these belong to alkyne group. The general formula of alkyne is CnH2n-2. That means when n is equal to 2, then we get C2H2. And for this, if n is equal to 3, then we get C3H4. Similarly, for that, here carbon number is 1, 2, 3, 4. That's why C4H will be 6. This is the molecular formula of butane. I think it is clear to you. The alkynes are named by omitting ANE from their corresponding alkane's name and adding YNE with it. For example, this is ethyne, 2 carbon containing alkyne. There its corresponding alkane is ethane. From this, at first we have to omit this one, ANE, and add YNE, and we get the name of this 2 carbon containing alkyne, ethyne. Such as for propane, 3 carbon containing alkane, propane, we can write it propine. Then 3 carbon containing alkyne is called propine. Similarly, for 4 carbon containing alkyne, we call butane, pentyne, heptyne, hexyne, similarly, so on. Now I will discuss about the preparation of alkyne. Let's start with the first member of alkyne group, which is ethyne. But ethyne is prepared by heating calcium carbide with water at very high temperature and then produce ethane gas and calcium carbide. Calcium carbide is a very interesting compound. In industry, it is prepared by heating carbon and lime at very high temperature and then produce calcium carbide. This calcium carbide is used for this industrial production manufacturing process of ethyne. Let's see how the reaction is taking place. The structural formula of calcium carbide is like that. Students, you can see here already carbon-carbon triple bond is present. So we doesn't need to create carbon-carbon triple bond for making ethyne. Just we have to remove this calcium and we add 2 hydrogen with 2 adjacent carbon, and then we will get the ethyne molecule. So that's why we have to hydrolyze it by water. We know hydrogen water molecule is made up of hydrogen and OH, and for this reaction we need 2 water molecule, because we know calcium is divalent metal cation. To remove this calcium we need 2 hydroxyl group, and then hydroxyl goes with calcium and produce calcium hydroxide as a solid form, and each hydrogen atom attaches with each carbon atom, and we get ethyne as a gaseous form. So finally the reaction, calcium carbide reacts hydrolyzed with 2 molecules of water and heated and produce acetylene gas and solid calcium hydroxide. And by this process in industry, ethyne gas is produced, and the commercial name of ethyne gas is acetylene gas. So that was the preparation of ethyne. Now I will discuss some chemical reactions of ethyne. Like alkene, this group is also unsaturated hydrocarbon group, and we know all unsaturated hydrocarbons have the tendency to become saturated. That's why, and this happens by addition reaction. That's why AlKyne also give addition reaction, and addition reaction is the characteristic reaction of any alkyne. Here also at first we will discuss about addition of hydrogen. The ethyne molecule, this we add hydrogen, but this reaction is a two-step reaction. At first, triple bond converts into double bond by the addition of 1 molecule of hydrogen, and after that this double bond is converted into single bond, and the compound get unsaturation. Look at this reaction, and we know for hydrogenation reaction, this is a hydrogenation reaction, addition of hydrogen is called hydrogenation. In this hydrogenation, the condition, of course, in presence of nickel catalyst and 180 to 200 degrees Celsius temperature. This reaction is performed at 180 to 200 degrees centigrade temperature and in the presence of nickel catalyst. And then we know one pi bond is breakdown and produce, and now in order to fulfill the tetravalency of hydrogen carbon, we have to add 2 hydrogen. And then another hydrogen molecule is added to it, and this double bond is converted into single bond and fulfill the tetravalency. Hydrogen is added. To write, my board is too short, too small to write a chemical organic reaction properly. So you have to try to understand this properly, okay? Then this is the saturated hydrocarbon alkane. We can write it like that, which is ethane. Then student, I repeat, ethane is react with hydrogen and in the presence of nickel catalyst and at 180 to 200 degrees centigrade temperature, and produce by a two-step reaction a saturated hydrocarbon ethane molecule. This was the addition of hydrogen. Now I will discuss about the addition of bromine solution. Bromine solution. We have already know about that reaction. This is the bromine test. We know unsaturated hydrocarbon give this reaction, and like alkyne also give this reaction, and by this reaction we can prove it alkyne is a unsaturated hydrocarbon. Then this reaction also addition reaction, also follow the addition reaction mechanism. Then I know the bromine solution is, we know the bromine solution is prepared by dissolving bromine in carbon tetrachloride, and this is a red color solution. Now this reaction will like that. This is also a two-step reaction. At first triple bond breaks, hydrogen and 2 bromine attaches to carbon atom to fulfill the tetravalency of carbon atom. Then this reaction, this compound added with another bromine molecule and produce bromine. Students, look carefully because my presentation is very bad on board. Okay, look at this. Two pi bond satisfied with 4 bromine atom, and finally we get a molecule which is like that, and this is called, the name of this compound is tetra bromo alkane, ethane. Okay, tetrabromoethane. Why ethane? Because here carbon carbon single bond. Tetra means 4, that's why here is 4 bromine atom are added to this molecule. That's why the name of this compound is tetrabromo. Bromine turns into bromo. Tetrabromo for 2 carbon ethane. Okay, and this solution is this compound makes the solution colorless, and that's the proof of any unsaturation. Now the another addition reaction of alkyne is addition of of water. This reaction is very important for you because the product of this reaction is very important for us. So here the product is a new compound to you, which is aldehyde. Let's go. At first we will know something about this aldehyde. Aldehyde is another homologous series. This contains a functional group which is CHO. CHO, monovalent functional group which is CHO. The structural formula is CH and double bond O. This group is called carbonyl group. This group is called carbonyl group. Then another product, another functional group is also present here, which is this group. This is the ketonic group. Both of these group is known as carbonyl group because in both functional group C double bond O group is present. C double bond O group is present. That's why these two functional group containing compounds are belong to carbonyl group compounds. But this is called if with carbonyl group one hydrogen atom is attached and other hand is fulfilled by hydrogen or alkyl group, then these compounds are called aldehyde. These compounds are called aldehyde. Such as if here H, this is H and CHO. This is the first member of aldehyde group because carbon number 1. After that, if CH3, this is the alkyl group with CHO. This is the second member of aldehyde group. This is ethanol because here 2 carbon is present. Like that, if 3 carbon present, then we call propanol. If 4 carbon is present, we call butanol. Student, listen carefully. I call L, butanol, not butanol. The naming of aldehyde, the aldehydes are named by omitting E and adding AL. AL, not OL, AL. So, the aldehydes are named by omitting E and adding AL with the corresponding alkane. That means for this is ethanol, ethane, omit E and add. From ethane, omit E and add AL, ethanol. The name of this compound is ethanol. Then we know about little about aldehyde, but ketone is not included in your syllabus. That's why we are not discussing about that. So only about this functional group. Then we can know what is aldehyde. If this CHO, monovalent CHO group is present in any organic compound, then we can call them aldehyde. And for this reaction, the addition of water with alkyne, the addition of mainly the addition of water with ethyne, we get a product which is ethanol, which is a aldehyde, which is an aldehyde. Let's how the reaction occurs. Ethyne triple bond. Ethyne. This is ethyne. Add water and have to apply a special condition. And have to apply the special condition. You have to remember these conditions. This is the important part of organic chemistry. Okay, these used reagents, conditions, catalysts are influence greatly the mechanism, the product of any organic chemical reaction. The condition is, here we use a special reagent which is 2%, which is a mixture, 2% mercuric sulfate, mercury, see Hg, the symbol of mercury is Hg, mercuric sulfate, okay, and 20% sulfuric acid. 20% sulfuric acid, that means it's a dilute sulfuric acid, not concentrated, okay, and the temperature is maintained at 80 degrees centigrade temperature, and then the product is, this is also a addition reaction. This is also a addition reaction. Don't be surprised, because we know concentrated sulfuric acid is dehydrating agent. Concentrated sulfuric acid removes water, but it's dilute sulfuric acid. It has no dehydrating property. That's why here easily can be happen the addition of water. That means hydration reaction. Okay? Here ethyne is hydrated by water, one molecule of water, and produce the addition product. My marker is not working properly. CH, this double bond, one of this double bond is broken down and produce, we know water molecule is made up of hydrogen and OH. This H attaches with this and OH attaches with this carbon atom. But this addition product is quite unstable. It is the intermediate product for this reaction. Okay, and after within a few moments, this product rearranged themselves. These products, the atoms of this product rearrange themselves and produce another rearrangement. Okay? Rearrangement, and then we get our desired product. Okay? This product is, look at this. This mechanism is not included in your syllabus, but for your better understanding, I will show you. Okay? This hydrogen atom come to this carbon. This hydrogen atom shifted to this carbon, attaches to this carbon, and then fulfill the oxygens, valency. This double bond transfers this position. This double bond transfers at this position. Then the product will be, look carefully, here carbon-carbon single bond, now H, here double bond, okay, double bond H, and here 3 hydrogen, C, 1 hydrogen, 2 hydrogen, 3 hydrogen, that's why CH3, CH double bond O, and this is the aldehyde group. This is the aldehyde group, and here 2 carbon are present. That's why, what is the name of this product, students? This is ethanal. Be careful. A-L. Okay? Not O-L. Ethanal. It's the aldehyde. This is the addition. This is the chemical reaction of ethyne, and also this is the preparation method of ethanol. Okay? This is the chemical reaction of ethyne, but preparation method of preparative reaction of ethanol. Okay, student. That's all about the alkyne for now. Now I will discuss about some derivatives of hydrocarbon. What is derivatives of hydrocarbon or hydrocarbon derivatives? The organic compounds which are derived from hydrocarbons are called organic hydrocarbon derivatives. That means the organic compounds which can be prepared from hydrocarbons are known as derivatives of hydrocarbon. There are many derivatives of hydrocarbon, but in our syllabus, that means in SSC syllabus, only 3 hydrocarbon derivatives are included. These are alcohol, aldehyde, and carboxylic acid or fatty acid. Then let's start with alcohol. I think all of you would have known with this word alcohol, because in many of our daily used chemicals like cosmetics, body spray, and nowadays we are using sanitizer to clean our hands properly. In all of these chemicals, alcohols are very common ingredients. But actually, chemically, what is alcohol? Do you know? Alcohols are the organic compound in which a hydroxyl group is present. A hydroxyl group is present. This is the hydroxyl group. When from alkane, one hydrogen atom is removed by or replaced by OH monovalent OH group, then it is called corresponding alcohol. For example, we can take methane. We also write it like that. If this hydrogen is removed by OH, then produce a compound. This is the corresponding alcohol of methane, and it is named as methanol. Methanol. That means the alcohol are named by omitting E, this is methane, by omitting E and adding OL from the corresponding alkane. This is methanol. The corresponding alkane is methane. The name of methane, from the name of methane, we have to remove E and add OL. Then we get the name of the alcohol. Such as for ethane, corresponding alcohol is ethanol. For propane, corresponding alcohol is propanol. For butane, corresponding alcohol is butanol. So on. The general formula of this alcohol is CnH2n plus 1, and this is the general formula of R group, alkyl group, and along this OH. That means we write the chemical formula of alcohol simply as like that. R. Okay, R is alkyl group, any alkyl group, and OH. This is the simple form of alcohol. Now we have to discuss the preparation of alcohol. Mainly we will learn about the preparation of ethanol. Only ethanol is included in your syllabus. Ethanol, the molecular formula of ethanol is this CH3 CH2OH. This is ethyl group and OH. This is ethanol. The first method to prepare alcohol is, we have already learned about that in our previous class, which is from ethene. If we hydrolyzed ethene, if we add water molecule with alkene, then by hydration reaction, it's addition of water. Hydration reaction, we can produce ethanol. And the condition is 300 degree Celsius temperature, 60 atm pressure, very high temperature, and we use catalyst as a catalyst, phosphoric acid. Then the hydration, this double bond breaks into single bond, and H from hydrogen water added with one carbon, and OH is added with another carbon. Then the product is CH2H, and this double bond turns to single bond, OH. And you can write it like that: CH2, CH3, CH3, CH2OH. This is ethanol. Okay. Another process of preparing ethanol is fermentation process. This is widely used process nowadays because the raw materials of last method, ethene, is a non-renewable hydrocarbon. It comes from petroleum, which is a fossil fuel, That's why we know fossils are non-renewable, and so nowadays it is very important to reduce the uses of non-renewable sources. That's why this fermentation process is widely accepted for preparation of ethanol. And for this we need glucose, C6H12O6. This is glucose. If this glucose is in the presence of yeast fermented, then we get alcohol, ethanol, ethyl alcohol. and water. And the temperature will be 30 degrees centigrade. Glucose in the presence of yeast, the yeast in here yeast releases an enzyme, a very important enzyme, which is zymes. In the presence of zymes enzyme, glucose converted into ethanol and water by fermentation process. By this process, we can also produce ethanol easily. Now I will discuss about some important, very few, two reaction about alcohol, ethanol. At first, ethanol in presence of concentrated sulfuric acid. In presence of concentrated sulfuric acid, produce a compound which is ethene, an unsaturated alkene. Produce ethene. We have already discussed about this reaction in our previous class as a preparation method of alkene. In this case, we know concentrated sulfuric acid is a dehydrating agent. It can remove water from any organic molecule easily. From ethanol, it removes one hydrogen and one OH and one hydrogen from here, minus H2O, and then we get ethene, CH2. This turns into CH2 and double bond is created to fulfill the tetravalency of carbon atom, and we get ethane. And this water molecule absorbed by concentrated sulfuric acid. This is the important reaction of ethanol. This reaction has great significance because by this reaction we can produce ethene. The second reaction, very important reaction, is oxidation of alcohol. Oxidation of alcohol. You have to remember this. What is the oxidation product of alcohol? If we oxidized alcohol, we get aldehyde. Aldehyde or a compound which is called ketone. Ketone is also a homologous series of in organic chemistry, aldehyde and ketone. The aldehydes are the organic compound which have this functional group. Which has this functional group is called aldehyde, and ketones are which have this functional group. CO. We can write, this is the structure formula of carbonyl group. This is carbonyl group, this is aldehyde group. This is only carbonyl ketonic group, this is aldehyde group. Okay? And these two products can be prepared by oxidizing alcohol. But now we have to see the examples and then it will be clear to you. For this oxidization reaction, we use a oxidizing, very special oxidizing agent, which is potassium dichromate and dilute sulfuric acid. The mixture of these two compounds, okay, potassium dichromate with dilute sulfuric acid, that means light sulfuric acid, and then this chemical combinedly produce a very important ingredient, which is nascent oxygen. It is presented by oxygen, symbol of oxygen within third bracket. This is also called active oxygen, very active, and we know for these oxidation reactions for organic chemistry we use the old concept of oxidation. We doesn't consider the transfer of electron here. This will be more complicated. We use the old definition of oxidation and reduction. Oxidation is the removal of hydrogen or the addition of hydrogen. Students, is it clear? We have to consider the addition of oxygen or the removal of hydrogen, and these are oxidation. Then the other product, not important, but I can show you this. The product will be potassium sulfate, sulfuric acid, sulfate goes with potassium, sulfate goes with chromium, chromium sulfate plus nascent oxygen. This nascent oxygen oxidized the alcohol. This nascent oxygen oxidized the alcohol and produced aldehyde. As example, we take ethanol, CH3, CH2OH. Okay. Now, nascent oxygen. I have already mentioned that only nascent oxygen is reacted, and the reagents will be shown here. 2 potassium chromate, potassium dichromate, dilute sulfuric acid, and then we get the corresponding aldehyde. The corresponding carbon atoms are similar for both cases. Here is 2 carbon, here also 2 carbon. Now, student, look at this reaction. Which definition of oxidation reaction is applied here? Removal of hydrogen or addition of hydrogen? This nascent oxygen causes here the removal of hydrogen. Look carefully, then you can easily understand. Here only this portion, consider this portion, 2 hydrogen, here 3 hydrogen, 1 oxygen. 1 oxygen in this product, here also 1 oxygen. So we can easily observe that this hydrogen is not added with this product, but he removes these 2 hydrogen atom from this alcohol, and we know the removal of hydrogen is also oxidation. That's why this reaction is oxidation reaction, and this oxidation occurred by nascent oxygen. So the product is water. It removes 2 hydrogen and form water molecule, and this alcohol converts into aldehyde. Okay, this is very important. This is very important chemical reaction, organic chemical reaction. You have to remember that. This is very important for your SSC exam paper also. This is the end of our today's lecture. Be happy, be safe, read properly and regularly. Of course, you have to practice these organic chemical reactions regularly. Otherwise, you cannot write it properly and correctly in your exam paper. And this organic part of this your chemistry book is very new for you. That's why you have to try hard to adapt these chemical reactions. Thank you, student. Assalamu alaikum.